So to kind of build on that, something that stands out to me as far as what OMG and Enya is working on is the Ethereum augmentation facet. So why is this significant, in your opinion, to the future of Ethereum?
Well, so over time, there's been a lot of advances in computer science, in the realm of data science, machine learning, statistical analysis, developing highly trained and battle-tested models out there in the world of finance and insurance and digital diagnostics, for example. But given today's constraints of smart contracts on Ethereum, you just simply can't implement these models, bring them on into a smart contract because you can only deal with integers in these smart contracts, and it will be too expensive to operate them directly on Ethereum. So it seems wasteful and unfortunate that all of these innovations that we've been the rest of the world have been creating are not available to decentralized applications that are running on Ethereum. And that's why we believe it's so important to work on augmenting Ethereum in bridging these gaps so that uh, decentralized application developers can take advantage of the advances that have been happening in these fields and not have to reinvent the wheel and try to always stay within the constraints of today's smart contracts.
Well, this is a question with a like super long answer. Sort of Alan has already touched on that. I mean, if you try to divide two floats inside a smart contract, you know that doing basic math in a smart contract is sometimes not so easy. And the important thing is also, given Ethereum's issues in scaling, it's not necessarily the case that we want to pack more and more and more stuff into Ethereum. And yet, somehow, we want to make it easier for developers to tap into this much richer repertoire of algorithms and compute possibilities. And there have been a few efforts to move in that direction. I mean, people, for example, might think of TrueBit and other approaches. And those are examples of directions we're looking into. And so generally, what you have to do is you have to monitor either L2 or L1, and based on what's going on in those chains, you have to then trigger off-chain compute. You have to do so ideally in a verifiable way, and results can then be fed back into the chains, just like an oracle would feed data back into the chains. Of course, doing compute is difficult in the setting of a distributed system for any number of reasons. Most obviously, that the miners all need to be able to agree on things, otherwise they can't mine, and that's one of the difficulties in like introducing complicated compute operations in a distributed system. So, but the L2s on some level solve this problem. They make it much easier to shard computation, and L2s are also a really great setting for innovation, because you can try things out and see if they work. And the barrier to you trying stuff out in the setting of an L2 is much lower than someone trying to fundamentally change, for example, how L1 works.